Good morning, everyone. Myself, Mohan MS. I am from SPC, Department of Civil Engineering. Today, I am conducting an technical seminar on impact of digging and urban roads and its management under the guidance of Mr. Revanna Siddhappa, Assistant Professor, Department of Civil Engineering, SPC, Bangalore. These are the contents which I will be covering in this seminar. Introduction, objectives, literature survey, methodology, applications, advantages, disadvantages, conclusions, and reference. Introduction. Digging or excavation work is common in urban areas, often carried out to install or repair underground utilities such as water pipes, gas lines, electricity cables, and telecommunication networks. While this work is essential for the smooth functional of cities, it can also have a significant impact on urban roads, leading to traffic congestions, damage to road infrastructure, and inconvenience to residents. The impact of digging an urban road can be particularly acute in densely populated areas with narrow streets, where even a small excavation can cause significant disruption. Digging can lead to road closures, lane closures, and diversions, which can affect the flow of traffic and leads to longer travel time of communicators. Additionally, digging can cause damage to the road surface, including potholes and uneven surface, which can pose a hazard to motorists and cyclists. To manage the impact of digging and urban roads, city authorities typically regulate excavation work through permits and regulations. The outline the rules and requirements for carrying out digging work. The regulations often include guidelines on the size of location and excavation sites, the timing of work, and the measures that must be taken to ensure public safety and minimize disruption to traffic. This causes the this causes the process. Objectives: minimizing disruption. The primary object of mining the impact of digging and urban roads is to minimize disruption to the community, including motorists, residents, and business. This involves planning and coordinating the work to minimize the impact, traffic flow, and access to building and residents. Ensure safety. Safety is critical objective in mining the impact of digging and urban roads. This involves implementation safety measures to protect workers to, and motorists, residents, and cyclists. Safety measures may include use of barriers, warning signs, and traffic control devices. Protect infrastructure. Protecting existing infrastructure is an essential objective in mining the impact of digging and urban roads. Maintain healthy functionality. Another objective of managing the impact of digging and urban roads is to maintain the functionality of the road networks. Reduce cost and time. Effective management of digging and urban roads can help to reduce the cost and time required for the work. Enhance communication. Communication is a critical objective in managing the impact of digging and urban roads. Clear and effective communication between stakeholders includes utility companies, contractors, local government officials, and community can help to ensure that the work is completed safely, essentially, and with minimal disruption to the community. Literature review. Klopper and Haddock conducted an economic analysis of utility cuts on pavement performance. The study found that the cost of repairing pavements damaged by utility cuts exceeded the revenue generated by the utility companies. Reddy and Rao studied the impact of road cutting on pavement performance in urban areas. The study found that road cutting caused significant damage to pavements and resulted in decreased pavement performance. Methodology, how it works. First, road networks. Based on that, analysis and assessment of road performance is done. Later, prediction and analysis of road will be conducted. Then, after conducting that, determine the objective of road maintenance will be done. Later, countermeasures resource of road maintenance is done. This is the methodology. Road network. It has literature review, data collection, traffic analysis, impact assessment, mitigation measures, recommendations, analysis and assessment of road performance. Defining the research problem. The first step is to define the research problem, which is this cost case is to analyze the impact of digging and road performance and urban transport. Literature review. The next step would be conducted through review of the relevant literature and resource studies in the field of road performance and urban transport. Data collection. The methodology would involve collecting data on the digging activities and their impact on road performance and urban transport. Data analysis. The data collected would be the analyzed using statistical tools and techniques to determine the impact of digging and road performance and the urban transport. Assessment of road performance. The methodology would also involve assessing the overall road performance, taking into account the impact of road digging activities. This may involve developing performance indicators such as travel time, traffic volume, vehicle speed, and air quality. Recommendations. Based on the analysis and assessment of road performance, the methodology would also include developing recommendations to mitigate the negative impact of digging activities on urban transport. Conclusion. Finally, the methodology would conclude summarizing the finding and the implication of study, as well as providing directions for further research. Prediction and analysis of road. The predict and analyze that impact of digging an urban road, several factors need to be considered. These includes location, duration, scope, traffic volume. To analyze the impact of digging an urban road, several methods can be used. These includes traffic simulation, traffic counts, surveys, GPS tracking. Determine the objects of road maintenance. Ensuring the safety of the road users. Maintaining activities should aim to ensure that the road is safe for all types of road users, including pedestrians, cyclists, and motor vehicles. Minimizing traffic congestions. Digging activities can cause traffic congestions and road maintenance should aim to minimize the impact on traffic flow. Maintaining the road structural integrity, digging activity can weaken the road structural and maintenance activity should aim to ensure that the road is able to handle the traffic load without any structural damage. Reducing the environmental impact. Maintenance activity should aim to minimize the environmental impact of digging activities on the road surrounding areas. Countermeasures. Research of road maintenance. Advanced planning and coordination is required, efficient equipment and techniques, communication and signage, night and off-pack work, public education and awareness. Applications. Traffic congestion management, public transportation disruption, pedestrian safety, environmental impact, economic impact. Advantages. Improved infrastructure, reduce congestion, increase safety, enhance accessibility, improve assisting. Disadvantages. Traffic congestion, increased air pollution, noise pollution, damage to existing infrastructure, cost overruns, reduced accessibility. Conclusion. The impact of digging and urban transport and its management is a crucial topic that requires through investigation and analysis. After conducting extensive research and analysis, it is clear that digging has significant impact on urban transport and its management. The evacuation of road and its streets can lead to traffic congestion, increase travel time, and reduce accessibility. In addition, digging can cause damage to underground infrastructure such as pipes and cables, which can result in service disruptions and safety hazards. To mitigate the impact of digging on urban roads and its management, it is important to implement effective planning and management strategies. This can include better coordination between utility companies and transport agencies, as well as the use of the advanced technology, such as GIS and real-time traffic monitoring system. Additionally, the adoption of alternative transport modes such as biking and walking can help to reduce the reliance on cars and alternative consumptions. References: L. Ramage, The Impact of Utility Cuts on Government Performance, Transport Research Board, 1997. B. Klupler and J. A. Adolph, Economic Analysis of Utility Cuts and Government Performance, Journal of Transportation Engineering, 1999. M.A. Khan and A.Q. Chaudhary, Impact of Utility Fencing and Government Performance in Urban Areas, Journal of Construction Engineering and Management, 2010. S.P. Reddy, D.D.V. Rao, Impact of Road Cutting on Government Performance in Urban Area, International Journal of Innovation Research in Science and Engineering and Technology, 2014. Thank you.